Good afternoon. We are frantically writing down IP addresses because, as you can imagine, with all this gear, something is going to go wrong. My name is Scott Stanfield. I'm the CEO of Vertigo, and I'm representing Team USA for my second session. This session is really about kind of what you see up here on stage. What we want to do over the next 60 minutes is something fairly ambitious, which we haven't tried to do before, and that's to do the equivalent of Hello World for smooth streaming. So let me tell you what we have on stage here. Oh, by the way, so Mike Hanley's here with me. He's been with me at Vertigo for forever, 10 or 11 years, and pretty much is behind the scenes of every project we do. So here's what we're going to do today. We're going to use this camera right here to set up a shot. So we have some nice color up here, and we have a clock to kind of show you what time it is so we can see what kind of latency we're getting. We have an IIS server. We have a video encoder. And then finally, we have Visual Studio running on this laptop. So our goal is to go from these photons to this screen, to that screen, to your eyeballs in 60 minutes. I already went over that. But this camera is, I think the first thing we're going to do, let's go to the next slide. Let me first back up and talk about this, because our first project at Vertigo was the Democratic National Convention, which was in August of 2008. That was actually the day after the Beijing Summer Olympics. And at the time, we were talking about high quality. So it was only a short time ago, of August 2008, just back at that point, we were only able to do what we called high quality, which looked good, but it wasn't quite high def. And I want to just dispel a couple things. SMPTE is the board that covers the standards. And in this case, the way high def or HD is defined, it is one of those two resolutions, 1280 by 720 vertical lines of resolution, or 1080 vertical lines of resolution. So whenever you see anything that says HD, it needs to be one of those two. Now, remember what I said, 18 months ago, we could barely do 1280 720. So the fact that we're at this point shows you this technology is moving very rapidly. Progressive and interlace is a hack from the 50s or 40s, I think, whenever the TV came out. It has to do with the raster scan, and they would paint every other line. And then there's a vertical blanking interrupt, and the raster would scan back to the top and do it again. So it's very easy to find interlaced video on the web today. If people are trying to pull it from old sources, you have to go through this really crazy mathematical process to pull that out and make it flat to progressive. Progressive is what we care about. If you're using an LCD display or plasma, everything that we shoot today digitally is going to be progressive. And finally, the frame rates that we care about, there's a lot of crazy 29.987. There are other frame rates that are not nice integers, but typically we refer to 24 frames per second or 30 frames per second. 30 frames per second is pretty much the minimum of what your eye needs in terms of information refresh. We always shoot for 30. 24, however, is a historic, it's what 35 millimeter or 70 millimeter film is shot at, or 16 millimeter. So when you go to a movie theater and you're seeing a cinematic presentation, you're typically seeing 24 frames per second. Now, it makes a big difference in terms of the perception of quality. I want to talk about this for a second. Granted, there's plenty of technology here. Most of this presentation is going to be in three parts. A little bit of 5 minutes of cinematography, because honestly, this is fun. These physical devices with buttons, for me, is just a lot of fun. There's a bunch of IT involved. To me, not so fun. That's why Mike's here. It's IP addresses and DNS settings and cache settings, and it's kind of complicated. And then the final part will be Visual Studio with a little bit of source code and blend, and that's kind of fun too. There's not a lot of design in this session. This is mostly, at the end of the day, it's just the nuts and bolts of running through the plumbing. So what we're going to configure this camera for is 720 by 30p. If you guys recall, for a while when television sets were first coming out 3 or 4 years ago with HD, there was 720p or 1080i. Forget 1080i. 1080i is interlaced. We don't really care about those resolutions. It's this middle column that we're shooting for here on stage, 720p. A quick word about aspect ratios. This screen that we're looking at, it's either the physical screen itself is either 4:2 or 3:2 aspect ratio. I don't quite know. But the old television sets, the old raster sets that you have at home, that's an aspect ratio of 4:3. Most of your laptops, if they're newer, are 16:9 or 16:10 aspect ratio. Film is either 1.85 or 239 typically, something in between. This is important in terms of the perceived quality of the video, because we have found that if you shoot even standard definition letterbox in 16:9, there's a perception of quality. just by making it look like something that you might see in a movie theater. Just having those black bars in the letterbox, for some reason, triggers us to think it's higher quality. So in this case, we really are shooting at 16:9. These concepts in the aspect ratio is important because eventually that will make its way into the design of your application and the size of the squares on the screen. And you can easily find yourself subtly changing those aspect ratios or squeezing by a couple pixels, and that's probably going to reduce the performance a bit because somebody, typically the CPU on your computer, is going to have to squeeze that information down or stretch it. You won't get as good of an image. So it's something important to keep in mind. Now, a couple more words on this before we continue. The red area, this pink area, is what we've been dealing with in television broadcast. This is 780i. PAL, you have a few more lines of vertical information, 576. The green area is what we're going for, 720p. You can see purple, there's a lot more information. Now, you can stream live SD today in software. At one point, when I thought I had a lot more time for this session, we're going to use there's a squeak here. We're going to use expression encoder to set up a live stream because this camera will spit out SD. So all you need is a powerful computer, set up expression encoder, send it to IS running media MMS. It's not smooth streaming, but it does work in a pinch. And for a while at Vertigo, we were, to our remote employees in a remote office, we were doing a weekly company meeting using that in standard definition. We've now completely switched to HD. The thing is, to make that jump from red to green, you need a dedicated piece of equipment to help you with the encoding, especially because it's not going to take that signal and chop it up digitally one time. In our case, it's going to do it 4 times, 4 different bandwidths and 4 different resolutions. Because the client, depending on the horsepower of your CPU at the time, or depending on the speed of your unique connection, might only be able to handle a certain amount of data coming over the wire. Ideally, at least for the Olympics, the maximum resolution was 1280 by 720, so it's true HD. And if you had it was either 3 or 3.5 megabits per second, you were able to see that HD quality feed, and it was brilliant. But not everyone in the country, in the US at least, has 3.5 megabits per second. So there's diminishing. It will follow some kind of normal distribution or bell curve in terms of what the magic resolution is. And that's really important because that will have ramifications on the bandwidth you pick. By the way, just as an aside, this is another scale to show you. This is where we are 720p and at home. 4K. If you're in Vegas for next month at NAB, this is where cinematography is right now, at 4,000 vertical lines of resolution. So there's cameras like the Red or other cameras that are shooting an enormous frame. It turns out that's what you need to match a 35 millimeter film negative. So this is what we have in store. I mean, we're lucky to get 720p right now. I don't think I shouldn't say it, but 4K seems a long way away. But think movies like Avatar, they're shot on those really large frames, so they have a lot of color latitude and cropping area, and they have a lot of information that they can still keep as they transcode and get it down. So, all right, enough talking about this. I want to tell you about this. This is the Panasonic P2-based system. It's called the 170. It's a low-end pro camera from Panasonic. This is about $5,000. This is the low end. It has a fixed lens. It records actually to a little like a PC. Remember the PC cards or PC MCIA? It's a little card about this big, and there's an array of SD chips in it. So you got those little SD postage stamp chips, and they made it into a RAID array to increase. I guess it's RAID 1 for performance, and they write it to the back at 100 megabits per second. So to capture the high fidelity of color that you want, 100 megabits per second. Remember, for the Olympics, we were having to take that fire hose, 100 megabits per second, get it eventually down to 3.5 megabits per second. So there's a decent amount of loss of information, but our eyes are pretty forgiving and can make it look good. By the way, this is Microsoft provided this rig here. This is the camera I asked for. This is all kinds of fun stuff. This is for pulling focus and a matte box for putting gels on it and a battery pack and rails. And I'm not sure what the blue thing is, but it looks cool. Yeah. It's to carry it. Yeah, it's something that prosaic. So anyway, let's do this. Can you switch the, Travis, can you switch to the camera? Bring the house lights up for a second. Okay, so let me just show you what we have here. So I'm able to zoom in and out. And by the way, you guys all gave your consent to be photographed. So that looks pretty good. We have a nice little tripod. Oh, let me wait till he finishes. Go ahead, sir. I got to get this side of the room. Got to represent the guy in the back, the green. We could just spend the next 45 minutes doing this. Infinity. Oh boy, okay, I better hurry. So let's do this. Let me set up this table here with something interesting to look at, because you guys aren't that interesting to look at for the next 40 minutes. I'm sorry. But no, what we really have is this little clock. So we have, I was going to do this. This is our poor man's time code. To get a real SMPTE time code that inserts itself in this SDI chain is about $3,000. And this is about $30. So this is the way we're going to do it. I have a couple things here. Tell you what, bring the lights to 50, the house lights to 50, because my little set's kind of blown out. Let me do a couple things. This is like the 5-minute cinematography lesson, okay? So what we want to do very, very briefly is just to kind of compose our shot. And I want to be able to see the clock and this little focus card and the glass there. Now, see how the focus card is completely blown out? It's really white. I can control the iris, which will make it darker. So I'm just closing the aperture down in the front, so not as much light is coming in. Or did I have that backwards? I always get that backwards. So I've got the ability, just indulge me for a second. I can show you guys what I'm looking at on here and the display setup. Here we go. I actually went to, there we go. This is a really poor UI. Oh, there you go. Okay, so this is what I'm looking at. So there's this thing called Zebra, and it's showing me when I tweak the iris, you see like the zebra lines. Oh, you don't see it. Well, trust me, right here on my screen, this is all chopped up with vertical lines. It's telling me it's too bright and overexposed. So I just want to dial that down so I don't have too much light. Now, believe it or not, this does have an impact on the performance, because if I send it a frame that's all overblown or it's blurry, there's no reason to run through all the processing. So having a good, clean image all the way through is really important. Let's see. So we got the focus, we have the exposure, and the color looks good. One last thing we do, just to make this shot a little more interesting. This is a little focus book. These are very expensive. $300 for these things, and they have an expiration date. So apparently the pigment they print them on, because they want you to keep buying these books for focus, but this is the reason I bought it. So we have lots of nice skin tones to work with, and let me focus on these guys here. Okay. There we go. And those waves in the background, that's the only thing we don't really care about. That could be perfectly blown out in white. And okay, that's our shot. Oh, forgot. We wanted a little bit more color. I was going to stop by the florist to get some flowers for some color. Instead, I just did that. Cheaper, and they're edible when we're done. All right, perfect. That's our shot. So now, there's a cable coming out of the back of this thing. It's a coax cable with a BNC connector. It's called Serial Digital Interface, HDSDI. And it's not unlike your HDMI signal. However, this is shielded and can be run a very long distance. And it's what's used in professional ENG and broadcast systems, because there's all kinds of switching equipment, like Travis is about to demonstrate. You can switch it back. So he's got a single button. He can switch from different sources. So now we're back to Visual Studio in this area. So that's actually perfect timing. You can leave it there, Travis. What we're going to do now, we're done with the camera. We've set up our shot. Now what we want to do is configure our Internet Information Server. And this is a server quality, rack mountable Dell laptop that we're going to configure. So I'm going to have Mike. You want to set it up?
Sure, yeah. Sure. So if we've already pre-configured our server with IIS Media Services 3, if you guys need to get that, there's a really handy tool that Microsoft has.
This is the WPI, or Web Platform Installer. This box really is relatively clean. Windows 7 with IIS. Okay, and then we just did exactly what Mike is doing. We're installing the Web Platform Installer.
Yeah, we just run this. It's a very lightweight package that Microsoft put together. But what's great about it is it lets you set up a new web server basically with all the different pieces. So we've already pre-configured it, so it should show up
Media Platform.
Media.
Second one, yeah.
And here. So you can see we already have Media Services 3.0 installed. It's important to make sure that when you guys do this, you want to do 3.0 because 3.0 is the only bits that support live. So we have that set up. What that does is it adds a few extra features to IIS. Basically puts in your websites, it basically puts in a handler that will take an extension that Bob will be getting into a lot more detail in the next session. But basically there's an extension called ISM or ISML. And the difference between ISM and ISML is really just one is recorded content and one is live content. So you're going to media services, go into live smooth streaming, and we're going to set up what is called a publishing point. A lot of times once you start setting this up a lot, they just call it a pub point. Basically, we're going to have the encoder feed IIS information. And then IIS is going to broadcast the information out to either our players, our Silverlight applications directly, or to a large CDN like Akamai's CDN, and then the players connect directly to Akamai.
So this is basically, it's a named point, a publishing point. So we're going to take whatever Mike calls it. We're eventually going to configure our video encoder.
So
we'll call it MIX 2010.
Yeah, let's call this MIX 2010. So we'll just put in a title. And we're going to put in an estimated duration here. What do we have left?
Well, it won't be more than 42 minutes, 60.
So we'll call it 60 minutes. Again, we're going to push.
Or maybe, actually, 59, just in case. I don't know what, because that would be 1 hour, and who knows.
We have some other options in here, which is, again, really nice about smooth streaming is that once we lay down the information, we can instantly have it archivable. We can, and Bob, again, we'll get into a lot more of this as we go into the next section on how we did this for the Olympics. We can set up a DVR window, so we can actually have it like TiVo or a PVR where you can have a certain buffer or an amount of time that you can scrub forward, scrub back. So we'll go ahead and do that, and well, we'll just do it for the whole thing because it's short. And we'll skip. We're running low on disk space on our server, so we're going to skip archiving. And then that's it. That's all we have to do. Now, basically, we just start it. So as soon as we do this, this box is now, this server here is basically in a mode where it's waiting for requests. And so you can see there's this ISML file here. If I actually go and open it up, I'll just throw it in Notepad. What you'll see here is just a few pieces of metadata. Some of these you can tune for better optimization. Like, for example, look-ahead chunks is something that we typically tweak with Akamai, so we might bump that up to 2 or for 3 or 4, something like that. But basically, out of the box, you don't have to do very much. What's interesting, though, is if we try to bring this up in a browser, and I just go to localhost, and
MIX10 or MIX 2010?
We want 2010. So you'll notice a couple things. First, you notice if we try to hit it, we're getting a 404, even though the file is actually on disk. The reason this is because it's actually going through a handler here. So you can see there's a module called Live Streaming Handler. It won't actually start working until we actually have an encoder pushing content to it.
Which is a perfect segue.
Yes.
So invite our next guest up on stage.
So let's have John from Inlet help us explain what it is how we're actually tying the knot between that camera and this server.
By the way, look at this. This is a photo that one of our guys took. This is in the hotel room, actually. So we can license it to you, John, if you'd like. But this is the blue box here on stage.
So, do I get the picture instead of the flowers you're going to bring?
I don't have my own.
You can have the M&Ms. All right, is your mic on?
I am now.
Okay, great. So why don't you explain what you got, and you can use that diagram to walk us through it and what you guys do.
So as Scott talked about, what we have on stage here is we've got the element of production, which is the camera and the M&Ms. M&Ms are a requirement in production, I believe. And we've got this notion of distribution, which is this heavy-duty rack mount machine server that we've got going on here. And what I'm here to talk about, and what my company does, is we make something called, we make media preparation solutions. So what does that mean? We take content from production and get it ready for distribution. So we're really this conduit or this bridge of getting from a source, like a camera, out to an audience like a mobile environment, a smooth streaming environment, or something that's going to go out over IP. So as Scott described, we've got a camera source coming into this blue box down here over this coaxial cable called SDI. It's actually coming to us as a uncompressed feed, roughly at about a gigabit per second. So we're getting a gigabit per second across this little coax feed. We unplug it, bits go everywhere, and it's quite a mess. The box takes that data in and has a bunch of presets on there. And it says the box is basically asking you, what do you want to do? Where are you going to go with this content? And by that, you're really asking the question of who's your audience. In this case, we're going to show this content playing back on a desktop display, so we'll talk through that in a little while. But this box is preparing the content for distribution. So it's taking this 1.5 gigabit per second feed, and it's doing a lot of crazy math at this point. It's going to get it down to this 3.5 megabit per second stream that's going to go output. That's going to go output to the server here. And in this environment, what you've got here, just illustrated, is a typical illustration of how smooth streaming would work. You actually, in this case, you see two encoders. They're worked in what we call a teamed fashion. And so you have each encoder is putting out, you see these different lines coming out the encoder. Each encoder is putting out a unique stream. And in this case, it's representing the top encoder is putting out 4 streams, and the next encoder is putting out 4 streams. And these streams vary by bandwidth and by resolution. So as Scott indicated, that there's a variety of different resolutions out there. There's SD, there's different flavors of HD, there's even cinematic resolutions. As you're doing encoding, there's not this one-size-fits-all as you distribute it, especially out to an open internet environment or to a mobile platform. As we know, our bandwidth connections at home can vary wildly. If you happen to open up iTunes and download something while you're pulling down mail and you're watching something on Hulu, you're going to get a whole lot. Netflix, there you go. Netflix. Punch.
That was mine. That was our client.
Appreciate the plug. Since there's not this one-size-fits-all on bandwidth, what you do is you actually adjust the resolution. So to maintain a common quality, the things you're always adjusting is you adjust the resolution, you can adjust the frame rate a little bit, and you put out these varying data rate experiences. And so that's what the team's going to show here. Mm-hmm. Yeah. They're going to show this box, putting out a bunch of different experiences that are going to push out to this, again, this robust rack mount server here.
Awesome. So Mike's going to come up and configure the spinnaker. And you're around basically for glorified tech support.
Sweet.
So basically, when John shipped this box, we did a little bit of work. We literally all we actually had to do was set the clock to the right time zone, and outside of that, it was pretty much ready to go. Like John said, we have a bunch of presets. What we did is we started with their Smooth 4 H. Oh, not that one. Which one did we start with? Here it is. We started with the 720p Smooth 4 streams. And we basically took those and we created our own custom preset that we have loaded right now. And then we went in, and I'll just kind of show you guys the different pieces. The first piece is to acquire the source. One thing that Scott said in the beginning, it's actually not quite true. We were shooting for 24 or 30 frames. Turns out actually this, and this might have been just a last-minute setup glitch, we're actually pulling this out at 60p, which...
No, that's right. It's just leave it. Trust
yeah,
me.
it's fields versus frames.
Yeah.
So not a big deal. We'll leave it. You can see a preview, so if we were to move it, or you can see the clock is kind of updating slowly. So we get a little nice input. So this is one of the things we do right away is we make sure that the encoder is actually giving us the right data, and you can see Scott, kind of. So this is all good. So we know we have input. We then go to the basically the output. And so there's a variety of different output types. We're doing this all in VC1. You could use H.264 with everything we're showing you here. We just chose VC1 as it was what we've been using for Olympics and things like that. But you could also do H.264 as no problem. What we have, again, is 4 streams. We can. This is basically the. You can see here we have the 4 different streams. You can see the bit rate of our top end stream is 2.5 megs, and the resolution is 1280 by 720. Which is 720p. So if we pull down the middle or towards the end, you can see this one drops down to a meg, and it's 640 by 360. So slightly smaller. We're decreasing the bit rate. We're decreasing the resolution, preserving the aspect ratio. And then in here, we have output. We're outputting to the IP of this server, the IS ingest box, and then we just gave it a name. Now, we actually need to change the name because we called it 2010. So I'm just going to fix that.
Can I make a feature request, John?
Sure. Feature request away.
Can we make it so we only have to do this in one spot? Because watch, you have to do it in 4. Next time.
Actually, we have a beta out right now that actually allows you to auto-publish to all those fields.
Oh, nice. I did not know that. I really did.
Feature request noted, Scott. You'll have it soon.
Good.
And done. There. So now you can see it says custom because I've modified it. We're going to go ahead and save this in case we do something to change it. So we're just going to store it. And then that's it. That's literally all we have to do on the encoder. So we just hit start. Oh, yeah, that's because we already started the publishing point. So in a few seconds here, did I click?
Let's hit the manifest. Cool, I hit the manifest. Oh, scroll down, actually. This is a really handy debug window. So now it's being pumped through the encoder. So we should see the seconds ticking away. Now, on screen here, oh, this will be interesting. Actually, can you switch back to the screen for a second? Leave that mic. Leave the scroll down. Switch back to the camera, I mean. So we're at, in a second, I'm going to show you the time. I forgot to show you one thing. How many of you, just a side question, when you use your little point and shoots and you're here at the convention center and you take photos and you go back and look at them and they're all blue or all very orange? There's one last thing I forgot to tell you. It's because your eye, check this out, your eye I love doing this. Blake taught me this. He was a former photographer. Your eye knows what white looks like. Like, this is white because it says white. So this is officially white. So when you look at it, even in this light, you know what to look for. But when the camera looks at it, well, actually, that looks pretty white. Hold on. There, I can make it darker or kind of bluish. So I was looking for a bluish cast. In fact, if you look at the clock, watch how the clock is changing. I'm kind of toggling between 2 different white balances. That's because the camera can be set up to compensate for indoor tungsten light or outdoor sunlight at different kelvins. And you can also, if you want, zoom way in on, just get a lot of white on the screen, and then hit a little button on the front. The camera goes, oh, that's white. So now it has a reference point for everything else to be white. Now, I actually want the shot to be a little bit warmer, so I'm just going to tweak it again. But that was the last thing I really wanted to show you. Plus, I'm just getting a lot of mileage out of this $300 color book. Okay, so now take a look at the seconds that are ticking away. So we're at 3:29, and once it hits 30, can you switch back to the laptop? Now, 31, 32, 33. What does it say on there?
We're at 35, 6.
Okay, so this is already, there's just 40, 41, 42. It's actually very close, isn't it?
Yeah.
Good. Okay, so we're not enduring a lot of delay to here. But we're going to accumulate delay as we push it to this box, and then when we pull it down in our client here. So we're done with this, right?
Yeah, I just want to pull up the manifest file real quickly, and I'll just show you guys. So remember when I set up the server and I tried to go to that ISML file locally and it didn't come up? So now if I hit it, and again, that's just the IP of this box, and I put on manifest. So you can see this is actually now giving us data back. So it's giving us the different bit rates. You can see the 2.5 megs, the different the max, the width and the height, and then it has basically a bunch of time codes for each of the different chunks. And there's some other pieces of data in here that we'll get into later.
Yeah, the next session will have a lot more details on this. For now, what we're going to do is take that and copy to the clipboard because we're going to need that later.
Yep.
I'm sure. Actually, you know what? I'm going to blow it. I'm sure I will blow away the clipboard before we use it again. So I'm going to park it there. And because this is working, John, you can now leave the stage.
Awesome.
Thank you.
Tech support.
Yeah, exactly. Okay, so camera, check. Spinnaker,
Good.
IS.
Server's good.
Now we're in home turf. Now we're going to launch Visual Studio. And we're going to create a little player for it.
And while Scott's bringing that up, how many people in the audience have heard of the Silverlight Media Framework? Okay, that's good. A pretty good number. So we've been working in conjunction with Microsoft, and actually one of the lead architects is up here. So if there's any bugs, it's a good time to bring them up. Or if you like it, you can also tell them you like it. And Scott went up to the Codeplex page. So we've been working very hard. We've released version 1.1 of the, we call it the SMRF, the SMF, or the Silverlight Media Framework. And what we're going to be showing you is kind of a preview of the next release, a beta, if you will, of the 2.0.
Right. So here I'm in Visual Studio, and this is just our default Silverlight player. First thing I'm going to do is bring in the code base that we have, this beta version of Smurf version 2. Smurf 2, and I'll pull in the DLLs. And I'm about to bring in a file that cost us, 20 hours of hair pulling last night.
Yeah.
Turns out for live content, we just forgot, you need another file. There's a configuration file. I'll show you what that looks like. This config.xml, this needs to be deployed with your solution. This file has some important information that controls the heuristics of the underlying Silverlight Media framework that Microsoft built. I'm sorry, Silverlight Media Element, the SME. The SME and the Smurf. And then when we had Sunday Night Football, which was SNF, we had SME, SNF, SMF. Too much. But this is a really important file to have. We'll cover this a little bit later. Again, we just want to get Hello World. So just trust me on this. You need this file for live video. So we're back now. We can do a tiny bit of styling just to show you that this also works in Blend. I'm going to launch this in Blend 4. And since I've added the DLLs and components, I'm going to add now the player to my screen. So I'm going to Assets and search for Player. Drag that in. And I just need to make a quick tweak so it stretches out to fill the space. So I'll zero these out and save it. And just make sure everything's good. I'm going to press F5. And Visual Studio crashed. Did you see that? I think it crashed.
Yeah.
Still? Are we still in beta with that?
No, that's
Okay.
But you were in Blend.
I was in Blend? Blend stayed alive. Awesome. Okay, so we have our player here. Now, as you can imagine, we just got to connect the dots. So our player has a concept, this is new in Smurf 2, of a playlist. Now, we have a bug, so when I add a playlist, I'm going to get that, which is known and will be fixed. In the final, it's something with Blend 4. Of course, it's not our code, right? It's got to be Microsoft. No, I really don't know. All I know is you dismiss it and everything still works. So to this, I'm going to add a collection. So the new player will support multiple video streams. In this case, we only have one. So I'm going to add an item to our stream, to our playlist. And there's just a couple details. We need to tell it that this is coming from Smooth Streaming. It's a live stream, which will give us a little button that allows us to jump to the current live point. And then finally, the media source. And it should still be in my clipboard. Yeah, cool. And just for fun, I'll do it later. OK, that's it, right? Just those three things? OK, save that. F5. We still have the girls on here? There we go. That is live smooth streaming Hello World. Wow, that actually worked. It turns out trying to configure all this in a hotel room with you got a hotel room here at Mandalay Bay and you got 4 guys crammed in there with lights and a tripod and a camera. It looks kind of odd. Yeah, we were kind of wondering if they're going to call security. So that's awesome. Now, you guys see it just turned over 3501 on here. I got an idea. Let's compare the quality. We're going to go high definition. First of all, let me give it something to look at. So I'm going to, I don't know, I'll move the M&Ms. That's not really enough. I did. Watch, when I'm here, I'm 30 seconds in the future. I'll tell you how it works out. Now I'm back. So I just turned the beach picture over, and I'm going to go full screen. Now, what I want is to hit our maximum bit rate shortly, which actually has nothing to do with me turning the camera over. Still at 15.
Might take a little bit here. Let's see.
So on screen, oh, there we go. So that's me walking over and turning it over. So there you can see there's a little bit of delay. Now we are wired, right? It's not wireless?
Yes.
All wired? Okay. I'll turn it back over. Now, with more encoders or more bandwidth or faster web servers, I mean, you can get this up. I think with the Olympics or some of our big live events like Sunday Night Football, we were around maybe 15, 30, 45 seconds. Some of the delays are intentional, so we have an opportunity to insert advertisements, which is what we all enjoy. right? You're glad we make you watch advertisements. Well, we'll talk more about that in the next session. So this is good. So let's do a couple quick things. How are we on time? Excellent. Do we ever get up here? Okay, good enough. So let's close this. I'll go back to Visual Studio. I'm going to make a couple little tiny changes to the project. We can go back to Visual Studio, which I lost. Because it crashed. I didn't remember the project. What was it called?
I think it was Silverlight App 2.
Oh, MIX10 Player. So I remembered it.
Perfect.
Great. So I'm going to have it. So right now, it stretches when I move the window around. I'm going to kind of lock it into a particular size. So I'll go to the XAML for this, which is right here. And we can hard code at width and height. Width equals 640. I'm doing 640 by 400 because our Chrome takes up about 40 pixels of extra information. So that leaves that center rectangle at exactly 1/2 720p, which is 640 by 360. And how many of you have used Vimeo before? That's the Vimeo default rectangle size. It's a nice, convenient size. It fits on most browser windows. And by having this space here, as you can see, there's enough room for us to go into the HTML to decorate it. You know, we can put surrounding content. Because it's really important that we found to offer people an experience, what we call an in-player experience, where not only is there surrounding contextual information as to what the user's looking at, but also it gives you space to serve up advertisements. MIX10 Player. Hello. And I'm going to add one more thing. I'm going to go back to the player here and add a button on top of it just to show you we can do some very simple things with it. So I'll drag a button onto the player, and I'm going to make it anchor it to the bottom right instead of to the left and top. Now I'll slide it right over there next to the playlist, and we'll change the opacity so you can see through it a little bit more. Because at this point, you're just dealing with XAML, so this is pretty straightforward stuff. So inside here, I'll just set the width equal to 3/4 HD, which would be not a number I can remember. What was that? It was, hold on, calc, 1280 times 0.75. What, 960? Okay, somebody tell me the next number. Oh my gosh, I can't even. 720 times 9 divided by 16. And then I'm going to, no, what is it, 540? Okay. Oh, plus, was it 40? Mm-hmm. It's 40. All right. So now the idea is you can have a nice default rectangle size, but have it get larger for an in-page experience, and then go one step further and have the full screen experience. Now, there is actually one more feature we want to show you guys, and making sure we have enough time for. Mm-hmm.
One thing to note too is you guys may have noticed that the bitrate meter down there, it was stuck at 2 bars. As Scott gave it more real estate, the heuristics allowed it actually to scale up. So that's why you always want to try and optimize this kind of in-page or in-player state.
Yeah. Actually, I forgot to do something. I'm going to take this out for a second, and I want to compare what we're seeing here to what the raw image is. And we're going to do kind of an A/B test. And you can see it's actually pretty close. Let's bring this up in full screen mode. I'll let that go away. OK, so we're at 340 in 20 seconds. Can you switch back to the camera? Let me zoom in on something else. I'm going to try to get it as perfectly focused as I can. OK, now you're seeing some shine on the lights. Hold on. Oh my gosh, I will never find that shadow. Hold on. That's pretty good. OK, now do we have it on the player yet?
Not yet.
We got to wait 30 seconds. Any questions? Is this what you guys expected? Because I've been wanting to do this session for like a year. This is a lot of fun. Thanks. I don't know why. I still get, it's just exciting. You know what it is? I think, at least generalizing for men in particular, we have an obsession with remote controls and action at a distance, whether or not it's remote controls or laser pointers or guns or the ability that I can take an image on here and project on the screen for some reason is very exciting and probably potentially embarrassing. Yes? Is the compression affected by motion? Absolutely. Yeah. So Alex Zambelli did a full day media workflow presentation on Saturday. I don't know if that's streamed, but and I know that Ben Wagner, who's also a compressionist at Microsoft, depending on the quality of, or depending on the kind of content that you're filming, we're just using the default configuration, which is probably meant for live action, maybe moderate amount of movement. For something like the Olympics, where there maybe is a lot of movement, versus something like this, which is essentially a still shot with the exception of the seconds ticking away, yeah, you would configure things differently. But now you're getting into the way the groupings of pictures and B frames and C frames and some kinds of frames and stuff that it gets esoteric fairly quickly. Can you switch to the, everybody keep an eye on this. Now we're going to switch to the laptop. That's pretty close. That's really close. And remember, too, we're blowing it up on this big projector from the back, so we're losing a bit of gain as we go through. If you were looking at it up on the monitor here, it looks very nice. Switch back to the camera again. Yeah, so it's really close. So the quality of this technology is just stunning. And in the next session, we're going to talk a bit more about the features, other features as to why you might use this. I'm going to add one more thing to this. Let me pull this back out so you can see the seconds. One more feature of the Smurf, which is new. I'm going to show you how the playlist works. So we're going to add.
So you want to get the fish?
Yeah, so I'm going to bring this back up in Blend. Oh, by the way, the XAML underneath, I forgot I didn't show you the XAML. But is there a keyboard shortcut to make all this go away and just view this? It's like, I know it's one of these buttons, but no? 150 of you, and you guys don't, somebody's got to know this keyboard shortcut. It drives me nuts. That's what Blend is for. All right, open Blend. What do you guys think of Netflix on the Windows Phone, huh? That was cool. Yeah, so the theory, eventually, the idea is this kind of Silverlight media stream that we're encoding, it could be hit directly. It's more probably a licensing issue at this point. But as a prototype or proof of concept, that's the direction this is going. So you have one set of encoding for live and video on demand that can be consumed on mobile devices, laptops, desktops, Xbox. So that's really the direction we think all this is going. It's very exciting. Spinnaker Mobile. Are you encoding in your pocket? That's it's a big pocket. All right, so the last thing, we're going to go add to our player, go to the playlist.
Media, yeah.
There we go. I'm going to edit that. I'm going to add another item. So we do have another URL. And do you have it memorized? Because I don't.
Yep.
Adaptive streaming. And tell you what, let me make this bigger so
You want
we
me
can
to
see it.
type in?
Now don't write this down because it's not, well, you'll see in a minute why we don't want it live. What is it?
Streams.
Streams dot
Smooth.
vertigo.com
/ live dash MIX10
dot
ISML
/ manifest. Okay.
Perfect. And you should check.
Just making sure they're watching. Okay.
And then you just want to go back and check. Yes,
Make it live. Let's give it a title. And we're going to we'll give this a title, and this is Mix Stage. And I've got two little icons I'm going to add to our project. Add reference. No, not reference. Just
drag them in.
drag them in.
Yeah.
Pictures.
Yeah, sweet. Perfect.
There. I got to go back to the playlist. Okay, these are just thumbnails, so we have something to click on. And the thumbnail source is hotel. And this one is fish.
Perfect. Beautiful.
And we might have audio on this one, just for the guys in the back. Great. So bring this up in full screen. And now this playlist button has another source. So notice the time, 3:46. 3:46. And we should have audio. We don't. There we go. Oh my gosh, that is really loud up here. So this is a live tank back at our office at Vertigo. And I got to tell you, trying to keep a dozen fish alive for a week when you're far away is very difficult to do. I've got one last trick. Let's see. I'm going to call one of our employees at Vertigo, Kristalina. 3:47. How are we doing on time on that? That's 3:47. We're good. Wow. It's live still. I'm still amazed it's live. Okay. She's waiting for me. Okay. Do it, Kristalina. I'll just hang up now. Okay. Take about 20 seconds. So these are guppies, and it's funny. I asked one of my guys. I walked over to Dave Britton, who's actually working on the live stream for the whole session, and Stephen Piazza said, "Don't ask questions, but just tell me, how quickly could you set up a fish tank in the server room?" and you know what? It was working in 3 hours. He had gone to the store. I mean, the guys, both of our guys, they have just tons of knowledge about fish. And I can also tell you, this is the world's most expensive screensaver. We put the lights on a timer. Watch it for a second. Come on. It's like 40 seconds away.
We're going to add a button that says feed fish. You guys can feed them.
Oh, I saw it. There we go. She's so dramatic. Woo! All right. I can't really communicate. I think she's going to feed the fish now, actually. We didn't know if they're going to be active or not, but they're beautiful fish. And they're tiny. They're about like as big as your pinky right there. All right, here comes the food, I think. I'm going to turn this down. So we'll just let this go in the background. Let me tell you something else. So we have another session coming up at 4:30, so right after this one. You can bring the house lights up. We'll take some questions. We have another session coming up where we're going to go into, now that you've done the hello world of smooth streaming, is how to make money with this. And what it's like to put on something on the scale of the Olympics. And it's easy as it turns out. It's very easy. You just deploy this to Azure and you're done. Now, so here we go. I think they're feeding the fish now. That's what all the activity is at the top. So there's a mic in the back. We have a perfect amount of time. They want us to give 10 minutes for questions, but like I said, we'll be up here to answer questions. We're going to get set up for our next session. If you don't want to stay, that's cool. You can come up, have an M&M. But I appreciate you guys coming, and enjoy the rest of Mix. Yeah, go ahead. Take a question.
Do you want me to ask here up there?
I can hear you from here.
Okay. I come from a country where broadband isn't that nice.
Yeah.
And not a lot of people have enough speed to do the HD feeds.
Right.
One thing I haven't seen yet, and I don't know if it's possible, is when presenting a smooth stream solution to scale the video size when you're at low bit rates.
Right.
And so, because the user usually gets a full-blown window that's been programmed in the lower resolution, the lower bit rate.
Yeah.
See what I'm saying? Is that possible?
Is it possible? Or, I mean, first of all, you can...
So automatically change the window sizes. If I start with a low resolution...
Sure. So your code can say, oh, it looks like I'm getting a feed right now of 720 vertical pixels or maybe only 360. You could programmatically change the scale as well. We don't typically do that. We think it'd be kind of odd to have it. The problem is because it might be every 2 seconds it could be changing.
I got you.
But you could give them enough control to let them dial in their preferred experience. Or my suggestion is just to simply create a very low bandwidth stream of animated GIF images.
Okay.
Yeah. Not really. Don't do that.
Scott, if I could just add to that just quickly. I mean, one of the nice things about adaptive bitrate, we call it adaptive bitrate, and that's what smooth streaming is, but it's really adaptive bitrate and resolution. And so one of the things that we talked about earlier, we had 4 streams at varying resolution. The nice thing about the heuristics that Scott and the team has in there, it's looking for a variety of things. It looks for what are your decode capabilities, so what can your PC physically play back, but it also looks at your bandwidth characteristics. And so decode characteristics are more built on resolution as opposed to bandwidth. So if you've got data, there's no reason with adaptive bitrate and smooth not to do a high-end stream for even if it's a small percentage of your audience, because it could always adjust down. So you can see here these streams, you've got high data rate, high resolution, lower data rate, lower resolution, and it keeps going down. It's a tiered system.
Yeah, it's a good question. Thank you. Hold on. Okay, sir, go ahead.
Has any work been done on the coding part or some of the moving pieces of this puzzle for reducing as much as possible that delay for scenarios where, like gambling here in Vegas,
Right.
sport gambling, which that 30-second delay is like unacceptable. How close have we got to be able to be like real time?
Yeah, good question.
So we've got latency down end to end under in the couple of seconds range. So from the time
over dedicated pipes?
it actually
from
is shot here to out on that player, well not that player, but
Yeah.
the player screen up there, to 2 seconds end to end. And it can actually happen over an open network. Now what you lose there is you lose some of the resiliency of having buffers built up in the player and
right.
at the server side. So if you have a network hiccup, if you will, you might have a buffering type characteristic happen, but you can get your end-to-end latency pretty low. And we actually have powered, our encoders have been used for several auction events, sports betting, and financial institutions where latency is a requirement. You have to be very, very quick. Very little latency.
Yes, over there in the corner. Oh, let's repeat the question too. Add delay? Probably in the encoder. So the question is, how do you add delay if you want to add delay to the stream?
You can do it in a lot of ways. I know in the next session you guys are going to talk about how it was done for the Olympics. We have a capability of delaying in the encoder for ads as well. But you can do it at the encoder, you can do it at the player, you can do it at the CDN. So there's a lot of different levels that you can actually add in delay. Just depends on where it makes most sense. I think it probably makes more sense to do it earlier in the pipe, because if you start delaying at the CDN, you're sending out 2 streams out of the CDN. You send a primary and a delayed feed, and then you're just using up more egress data rate, and that doesn't make a lot of sense. So.
Good question. All right, that looks like it for the. Oh, we got another question. Go
second
ahead,
one.
Jeff.
Green M&Ms.
H.264, if you are streaming an H.264, is there a container on the video and that portion? I mean, is there a possibility of using a container on top of that, like Matroshka or any other, which can add additional functionality like chaptering, or is that everything done programmatically on the player?
Catch that?
Alex.
So
no.
Silverlight's the client.
Oh, there's Alex.
So in the case here, when we use streaming, we basically use board as our container.
Hey, Alex, you want to grab the mic so they could get on the recording? Maybe the one in the back, or they might have an extra handheld.
Here you go. Come here.
No, that's all right. So Alex Zambelli works for Microsoft and is he's the one that put on the session for the smooth streaming or video workflow on Saturday.
Anyway, so
Is that working? You guys here?
can you hear okay? All right,
Yeah.
thanks. So to answer your question, so smooth streaming is based on the MP4 file format. And what we do is basically we use it in what's known as fragmented MP4. So both when we do VC1 encoding with WMA audio, or if we do H.264 encoding with like AAC audio, for example, we use the same file format as the basis for it. So to answer your question, you can't really necessarily tack on like another file format on top of it, because smooth streaming already is basically contained in an MP4 file. So it's just coming in fragments instead of coming as one long file.
We will show in the next section, we will show some demos where you can actually see how we actually add some additional data, like metadata, like text and things like that, into the actual container, the fragmented MP4. So you'll kind of get an idea how to do that if you stick around for the next session.
Yeah, so a lot of the advanced features that you're looking for basically that come with something like Matroshka or like other containers actually is already supported in smooth streaming.
Cool. Is there a question in the